Well, it's been working absolutely perfect for about the last month. And then the other day I went to turn this thing on. I get a green standby LED, but I never get a speaker relay click. So that tells me there's something wrong with the output. The STK404-140 that I put in there, I think it's just a faulty chip. So I did go ahead and order a replacement. Kind of hard to see through this packing material. Let's get it out of here. I did go ahead and order a replacement STK404-140S, the Sony. And even the back of the chip has 404-140S. So let's go ahead and put that in. Hopefully it remedies the situation. As far as the previous problem that I was having with this unit, the crackling and whatnot, totally gone. Worked great, like I said, for about a month. So worst case scenario, if this does not work out, this is a 5.1 channel amplifier board. It has 5 audio outputs, 140 watts per channel at plus or minus 60 volts out of a Denon receiver that I scrapped out about a year ago. I'm going to go ahead and slice one channel off of this and mount this one channel discrete power amplifier board in the subwoofer. And I don't think we'll have any more problems. But before we do that, let's see if this is actually going to solve the problem. Okay, so I've got the unit open here, and there is the STK chip, the 404-140 that was replaced. And I had to add the bypass caps to get the hum to go away. And I don't think that was the problem. I'm suspecting just a cheap Chinese chip at this point. So let's look at the schematic. I'll show you a couple test points. We'll make some measurements. So here is the schematic. And so I want to measure on pin 10 to make sure I have my minus 58 volts, and pin 11 to make sure I have my positive 59 volts. Well, approximately 60. And then, because this is a misprint, they did not put the other 0.22 ohm emitter resistor on here. I want to check pins 12 and 13 to see if I have a DC offset. And that is what I'm expecting to see. So let's get to it. Okay, so I have my voltmeter set up here. It is in the 600 volt DC range. So I'm going to measure pin 10 and I have a negative 66 volts. And pin 11, I have a positive 66 volts. And now 12 and 13 are the speaker outputs. And I see negative 66 volts, so I'm betting it's got a shorted output transistor in that chip. So let's go ahead and kill power to it. We'll wait till this thing discharges. Just to be safe, we'll go ahead and unplug the connector from the amplifier board to the main board. That way there's going to be no voltage on this board. So checking pin 10, 0. Pin 11, 0. Pin 12 and 13, 0. So let's go ahead and put this in ohms. And we'll measure from pin 10 to the output leads. And I see 1 ohm. So the output transistor is indeed shorted. So let's go ahead and slam the new chip into it and see if that takes care of the problem. Definitely had adequate heat sinking. And incidentally, when this thing did quit, I checked the temperature of the heat sink just by putting my hand over the back of the unit, and it was very cool. We were playing this at a moderate level, probably I would have to estimate between 5 and 10 watts RMS at that point. We weren't really pushing it, just had some background music going, we were cleaning the house, and all of a sudden, no bass. And like I said, this thing had been working perfectly for almost a month with no issues whatsoever. All right, well, I'll start by going ahead and pulling off those 2 capacitors that I added to this unit to prevent the hum. Hopefully they'll cooperate very easily. There we go. Now we'll go ahead and just desolder the chip from the board. There we go, all desoldered. So there are the old chips, well, new-ish old. the 404-140 that I put in there. The reason I decided to add the capacitors to the inverting and non-inverting inputs, pin 3 and 4, was because if I simply just put my voltmeter on either pin 3 or pin 4, the capacitance of the voltmeter actually stopped the hum completely. So that's why I chose to add those capacitors on those 2 pins. Now there was a different commenter that said I could short the input pins on the connector from the main board to the amplifier board, and that would alleviate the problem. And I actually was going to pull this thing back out, tear it apart, and try that and see if it made any difference. Anyhow, I just think that this chip was just bad, a cheap Chinese knockoff. And I'm sure the replacement 404-140 is exactly in the same boat. So hopefully I don't have to tear that Denon board apart and use discrete transistors in this unit. Hopefully this will work. So I'm just going to go ahead and add some heatsink compound on the heatsink right here. Just make sure it's all saturated very well. And then I'm going to do the same thing on the back of the IC just to make sure it has good thermal conductivity. And I do expect a lot of this to ooze out, but that's perfectly fine. This is a very thin heatsink compound. We'll go ahead and mount it in place and tighten up the screws. So I'm going to start by just hand threading the screws in here, just to make sure they don't get cross-threaded. There we go, nice and tight. Let's go ahead and solder it up now. There we go, it looks absolutely perfect. Okay, here we go. Let's make some voltage measurements. For those of you curious, my negative lead is attached to the shield of one of the line input jacks. So we'll go ahead and reconnect the cable to it from the main board. There we go. Let's go ahead and power this thing on and see if we get a main power relay and then a speaker relay click a few seconds later. There's the main click. And I still have the exact same hum, even though this is a 140S. That is what it sounded like. And so the reason I went ahead and put those caps on was because if I measure from pin 3, the hum goes away. Pin 4, no hum. Pin 1, nothing. 5, nothing. 6, 7, 8, 9, 10. A little bit on 11. 12 and 13, which are the speaker outputs. But that's the hum. So I may have to add those caps. It almost sounds like this chip is a regular 140. So one of my commenters said that if you jumper pin 8 and pin 9 together, the hum will go away. So I think I'm going to try that before I add those caps back to it. So let's just go and put a solder bridge between pin 8 and pin 9 on that big connector coming from the main board to the power amplifier board and see if that does anything. So just with the ohm meter going from pin 8 to ground, I see 0.8 ohms, and pin 9 to ground, I see 0.7 ohms. So I'm wondering if there might be, because they get these grounds from different locations, so I'm wondering if this actually might work. So I'm just going to go ahead and short these pins together like that while it's running and see if the hum goes away. All right, power on. We'll put this in volts. 0. Oh, look at that. It does get rid of the hum. I'm going to put a solder bridge across that, and hopefully we will call this thing done. Okay, solder bridge is in place. Let's go ahead and give it another try. Okay, here we go. Power on. Main relay click. Speaker relay click. No hum whatsoever. Well, I'm going to go ahead and throw the back on this thing. We'll feed some audio into it and see what happens. Okay, well, the freaking thing lasted about 3 seconds. I didn't really even have it turned up that loud. I was just doing an initial test before I started the video on the outro. And so let's go ahead and check from pin 10 to pin 12. Nothing. Pin 11 to pin 12, I have 1.6 ohms. It shorted the freaking output transistor in this unit. What a cheap Chinese piece of garbage chip. So here is a nice zoomed in view of the replacement STK404-140. Not the original one, I actually threw that one away. But as you can see, definitely has some carnage right here. I believe this transistor has shorted, as well as possibly both of the output transistors right here. Unfortunately, they put the white blob on top of them, so I can't actually see the substrate to see if it's damaged or not. But we can do a couple quick ohm tests. So I do have the meter in the 600 ohm range. So if I short the leads together, I get about 0.6, maybe 0.5 ohms, depending on how things go. So let's just go ahead and check from the collector, which is the large tab. And I see 81 ohms. And I do see a 181 resistor right there. So that's probably okay. And here I see 0.7 ohms. That is definitely bad. 1.4 ohms I saw. And 0.6. That thing is absolutely toast. Cheap Chinese garbage. Holy crap. So let's go ahead and try to retrofit another amplifier into this unit and see if we can make it work once again. Okay, so these are my intentions. I'm going to supply the positive B plus right here. As you can see, plus 62 volts. I think I'm running at 66. I think it'll be okay. And the negative right there, minus 62 volts. Once again, I'm running about 66. I think it'll be fine. Now, this regulator transistor right here, all that it does is it takes the negative 62 volts and then it has a capacitor to act as a soft start, and then it supplies 62 volts up here to pin 2 that goes to the driver board. And now over here, this is the 4-pin connector that goes to the driver board. I'm going to supply audio to pin 1. And I'm actually going to use this 10 microfarad 50 volt coupling cap in this 4.7K resistor so that it's going to isolate the input audio, so it will be capacitively coupled. And then a 2.4K resistor to ground. Pin 2 and pin 3 both are ground. And then pin 4 is actually the audio feedback. If you follow it back over here, it actually picks up right here of the true audio feedback for bias compensation and voltage correction. So let's go ahead and take a look at the preamp board. So this is the little preamp board that's mounted on the main amplifier board. And I made some notes here. Pin 1 is the input, pin 2 and 3 are ground, and pin 4 is the audio feedback. And then on this 5-pin connector, pin 1 is B+, pin 2 is the B- regulation, pin 3 is ground, pin 4 is the positive drive to the output transistors, and pin 5 is the negative drive to the output transistors. So I'm going to go ahead and modify this board up and get it ready to put in this unit. And this thing, like I said, is rated at 140 watts RMS with like 0.01% distortion. Way more powerful than this little 404-140S by a long shot. So this is the schematic for the Sony amplifier board that uses the 404-140. So I'm going to take pins 1 and 2. That's going to be my B plus rail, 59.9 volts. Pin 3 and 4 are the speaker output leads. Pin 5 and 6 are going to be my B minus, negative 59 volts. Pin 7 is going to be my audio input source. And then pins 8 and 9 and 11 are all ground. Pin 10 is actually a 10 volt power supply for the protector circuit. And so inside this chip on pin 2 is actually a thermistor between 1 and 2. And the way that works is if this chip gets too hot, this voltage on pin 2 begins to rise. Once it rises enough, above 0.6 of a volt, it's going to turn this transistor on. And that transistor feeds the signal back through R710 to pin 12. I'm going to leave that disconnected because I don't really care about thermal sensing anymore. I don't think this thing's ever going to get hot enough because I don't drive it that hard over its lifetime. So basically, pins 10, 11, and 12 are just going to be unconnected, and I'm just going to leave them be as is. So let's go ahead and get started, put this thing in this unit, and hopefully we have a long-term solution for these cheap Chinese STK 404-140s that keep failing. Incidentally, I did check the voice coil resistance on the speaker, and it is DC resistance of 6 ohms. So I'm totally happy with that. I don't think that's an issue, but let's go ahead and modify this board, get it mounted. I'll have to drill the heat sink. I'll have to drill a relief for the bias tracking transistor. I'll have to fold the board over, add some leads to it so it'll fit, because otherwise it does not fit with the back on. And we'll get this all done, fire this thing up, and hopefully everything is golden. Okay, so since the STK404-140 obviously won't last in this thing, the cheap Chinese knockoffs, so I'm going to go ahead and put one portion of this 5.1 channel board into this unit. I have went ahead and removed the speaker relay, and I do have the preamp board completely unplugged from the unit right now, and there is the bias temperature sensing transistor right there. It's going to go on the heatsink a little bit later. Anyhow, that board actually just plugs on. You can see the connectors right there, they mate together. But the problem is this board's too high to fit in this unit, so I'm going to have to lay it down like this and extend the bias transistor leads to make contact with the heatsink, but I think it's going to be okay. This is basically just a proof of concept. So I have the two output transistors just sitting there, and I went ahead and I cleaned off the heatsink and I took a file and made sure it was perfectly flat. And so they're going to go right there. The board will mount basically right there, and then I'll have to provide some kind of a little standoff on the end of it here, right there where that screw hole is, to keep it upright. So I'm going to go ahead and mount those transistors right now. We'll go ahead and attach the board, plug it in. I still need to connect all these leads. The only things I need to connect are the B+, B-, ground, and then the signal, positive, and ground. And I think we're going to be just fine at that point. So bear with me. We'll see how this turns out. Okay, so the board is mounted, the transistors are secured and soldered to the amplifier board. I do have the audio leads just temporarily attached because I know I'm going to have to take this board off, add some leads to it, and lay it down flat because I tried to put the cover on this and it will not fit with this board standing up. But we'll take care of that later. I just want to see if it powers up and if the relay clicks and whatnot at this point. Okay, so I have it loosely assembled. I'm going to crank up the volume on it here. And it seems to be working just fine. It's shaking the camera. Keep in mind, I have this thing laying face down right now, and I don't have the baffle on the back of it or anything, and everything is just super loose back here. Nothing is secured at all. So next I need to go ahead and mount this board right here kind of sideways, flat, so that I can get the back on this thing. I tried to put the back on it and it just does not clear. But I think once I get the back on it, everything is going to be absolutely perfect. Okay, so the transistors are permanently mounted at this point, and I did go ahead and add some standoff leads right here to the preamplifier board so that I can mount the new board flat. And I went ahead and drilled a hole in the heatsink, not all the way through, so that the bias regulator transistor will fit nicely into that hole. I can add some heatsink compound to it, and it will make good contact with the heatsink and regulate the bias of these output transistors. Okay, well there is the board mounted sideways. Everything's ready to go, and I don't think I'm going to have any problem with having to secure this board because it's actually pretty doggone tight and it's going to be mounted vertically, so I don't think there's going to be any problem. Plus, this is my own personal subwoofer. If it fails, I've got 4 more to put in it. More than enough bass. So I'm going to go ahead and let this run for a few minutes. I'll set the idling current, and then we'll throw this thing back together and put it back in service. So this is the board out of a Denon AVR 5600. And in the service manual, there is no procedure for adjusting the idling current. It's currently at 2.4 millivolts. So I'm just going to bring this up, I think, to about 5 millivolts, and we're going to call it good because it's just going to be a subwoofer. So there we go, 5.1, 5.2 millivolts DC idling current. I think that's going to be absolutely perfect for this unit. I'm going to go ahead and let it stabilize for a few minutes. We'll check back on it and make sure it tracks correctly. Well, there it is, back in place. The Sony SAWM500. It's been working absolutely perfectly for the last couple of weeks, and I've driven this thing hard over that time. No more failures on this unit. Anyhow, it's up and running once again. Although it doesn't have the original STK404-140, it is rocking the Denon AVR 5600 amplifier. And it's actually putting out plenty of bass. I love it. It sounds absolutely perfect. I certainly hope you enjoyed this video on the repair of the Sony SA-WM500 when you cannot get an STK404-140 to work in its place. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, norcal715videos@gmail.com. That is the best way to contact me. Please be patient. I do have a full-time job, and I do this in my spare time. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody, thank you for making it to the end of this video. I really do appreciate it. Everyone have a great day. Thanks for watching. Bye-bye.